7.4 Reflections. In this section we look at line symmetry and reflections of simple shapes in horizontal, vertical, and sloping lines. In a reflection, a point will move to a new position that will be the same distance from the mirror line, but on the other side. So these distances will always be measured at right angles to the mirror line. So what does this mean? Here we have the mirror line. Okay, so A is the original position, and it is moving at a right angle and the opposite side of this mirror line, and A prime represents the reflected position. Similarly, if we look at B, we start here, it's reflected in this mirror line to end up over here. We label it B prime. Again, perpendicularly, the movement is perpendicular and on the opposite side of the mirror line. Okay, so this one vertical, this one, or vertical mirror line, this one horizontal mirror line. Here this one is on an angle, but the same rule applies. So originally C is here and it's a certain distance away from that mirror line. Okay, so the new one is going to be that same distance away but on the opposite side, and again perpendicular to the mirror line. Example 1. Draw in the lines of symmetry for each of the following shapes. Okay, so we have to look at this one and figure out what's going on. So I'm going to use a green hash line to draw in the lines of symmetry. So if we look at this shape, we see it's a square that comes out here, right? Sort of turns into a bit of a star. And so what are the lines of symmetry? Well, on this shape, if we look at it through here, we can rotate the shape along this line, okay, and get the same image, right? This point would be over here, right? This point would be over there, this point would be over there, okay? So we can see that we can rotate, and this entire half would be over here, and so that would be a line of symmetry. We could also do the same thing in this direction with a horizontal line. This point, for instance, let me use another color to denote this. That point, for instance, okay, if we called this A, right, it's a distance of 1, 2 away from the mirror line. So A prime would be again 1, 2 away from the mirror line, right? And here it is. And this line that we're writing to calculate the distance of how far away it is perpendicular to this mirror line. Okay, so if we're counting 1, 2 going up straight here, this line is perpendicular to this mirror line right here. Makes 90 degrees. Are there more? Are there more lines of symmetry with this shape that we notice? Give you a second. The answer should be yes, there are. We can also put one across like this on an angle. And so what that means is these shapes, if A is the original point, then we look at A and it is this distance, okay, sort of two diagonal distances away from the mirror line at a perpendicular. So if I draw it, it would be something like this. Okay, let me take away these two first so that we can make this a little bit clearer. Take away that one and take away this one, and I'll just leave the one that we're looking at. I will also, to make it even better, get rid of this. Okay, so now all we're looking at is this new angled line, okay, and we're saying that A is the original shape. If we decide that it's this distance away, perpendicular to the mirror line, then A prime will be that same distance away, which is that much, again perpendicular to the mirror line, and we would label it as A prime. And we can also find there's another line of symmetry, and it goes all the way along this way, and all of these points would be mirrored over onto this side. Okay, let's look at B. So again, we're looking for drawing in the lines of symmetry. Now this shape, which is actually maybe difficult to see on your computer, so I'm just going to color it in. It's like a chevron. Okay. And so that other one was quite symmetrical. There were a lot of lines of symmetry. This one won't be the same. Will not have the same amount. It depends. I mean, some shapes could have no lines of symmetry. However, looking at this one specifically, can we put in a line of symmetry? If we move from here to here, we are not going to get that bottom. But if we put it in this way, we can see that yes, absolutely, if we take a point, say this point, which is 2 away, then we flip it the other side of the mirror line, it will end up over here. If we took this point, for instance, which is 2 away, it would end up over here. If we took this point, it's 2 away, and it would end up over here. So yeah, you can see that there is a line of symmetry, and it goes right here. Example 2. Draw the reflection of each of the following shapes in the given mirror line. Okay, so this one we're starting with this trapezium, this shape right here. Just putting it rough so that, again, so you can see it on your computer. I want to make sure it comes in. And so, how do we do this? Well, we have to look at the mirror line. Okay, and we have to pick some points. So let's start with this point right here. It is 1, 2 away from the mirror line, perpendicular. So on the opposite side, it will move 1, 2, and its reflection will be over here. If we take this point, it's again 2 away, so it will be the opposite side of the mirror. That's it, reflected, point reflected. This one over here is 1, 2, 3, 4 away, so we're going to move 1, 2, 3, 4 away in the opposite direction. This one is 1, 2, 3, 4, so again we're going to do 1, 2, 3, 4, and we end up over there. And so we can see that the reflected shape using the mirror line in green is right like this. Okay, so same shape but reflected in that mirror line. Let's look at B. The mirror line is vertical, and we are starting out, original shape looks like this. It's a parallelogram. So we're going to reflect this parallelogram in the vertical mirror line in green. Okay, so we're going to take this point, it's 1 away, which means its reflected point is 1 away. This one here is 1 away, reflected point is 1 away. Let's look at this point right here. It is 1, 2, 3 away from the mirror line. We will move 1, 2, 3 away from the mirror line. This one here is 1, 2, 3 away from the mirror line. We'll reflect 1, 2, 3 over here. So you can see that this shape will produce a reflected shape that looks like this in that green vertical mirror line. Example 3. A triangle has corners at the points with coordinates 4, 3, 5, 6, and 3, 4. Draw the reflection of the triangle in, and we have 4 different reflections, 4 different mirror lines that we want to look at. So I've already drawn in the triangle. Here it is. Okay, so to do part A, we're going to look at a reflection in the x-axis. Okay, so to do this, I want to put in the x-axis. It's already here, but I want to highlight the x-axis. The x-axis is this one, of course. So to get the reflection, and we'll put the first one, A, in red, we're going to have to reflect around this line. Okay, this is the mirror line. So this point, we can pick points. This one is 1, 2, 3 away, so it will reflect 1, 2, 3, and it will end up over here. This point here is 1, 2, 3, 4 away, so we'll end up 1, 2, 3, 4, and it'll end up over here. This one is 1, 2, 3, 4, 5, 6 away, and it will end up 1, 2, 3, 4, 5, 6 away over here. And then of course we can join these points to make the reflected triangle. And that's using this mirror line right here, which I'm going to now delete. So we're going to do the same thing in the y-axis. So the y-axis, of course, is right here. And so I'm not going to color it in this time. I'm not going to use a hashed line to make it. We're just going to remember that this is the y-axis. So we can take points. Again, this one is 1, 2, 3 away from the mirror line. So we're going to do 1, 2, 3 away. It gives us a point. This is 1, 2, 3, 4 away. So we're going to go 1, 2, 3, 4 away. We'll take this one right here. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so those are 3 points, and then if we join them together, we will have the reflected triangle in the mirror line that it was the y-axis. Okay, now we're going to make our mirror line x equals 6. Okay, we're going to make the mirror line x equals 6. So x is 1, 2, 3, 4, 5, 6. Okay, so right here we have our mirror line, right? Everywhere along here, x is 6, x is 6, x is 6, x is 6, x is 6. So this is that line, and we're going to reflect this triangle in this mirror line. Alright, so let's use a different color. We're going to try yellow this time. 1 away, we're going to move 1 over here. This point is 1, 2, 3 away, so we're going to move 1, 2, 3 away over here. This one is 2 away. And again, every time I do this, I'm using a line that is perpendicular to the mirror line, right? I'm counting 1, 2 on this perpendicular line. And so over here, I'm making a perpendicular line, and I'm counting the same distance, 1, 2. Right? So I end up over here. And then if I join these together, we get a triangle that is reflected in the line x equals 6. Okay, so there's our mirror image along x equals 6. Alright, let's get rid of this one and move on to part D. And D is the line y equals 7. So we got to find out where y equals 7. We're going to put it in. So y, 2, 4, 6, 7. So that is the line right here. This is our new mirror line. And we're going to take this triangle and mirror it in y equals 7. Alright, so perpendicularly away it's 1, so we put 1 there. This one is 1, 2, 3 away, so we're going to go 1, 2, 3 over here on the opposite side. This one is 1, 2, oh, sorry, over here 1, 2, 3, 4 away. So we're going to go 1, 2, 3, 4 away. And again, we join these dots, or join the points, and you get the example 4. An L shape has corners at these coordinates, and I've drawn in that shape right here on this graph. And we want to draw the reflection of the shape in these two lines, y equals x and y equals negative x. So we'll start with y equals x. So what does that mean? When y is negative 6, x is negative 6. When y is negative 4, x is negative 4. When y is negative 2, x is negative 2. When y is 0, x is 0. Okay, so if we use that, then we see that it is a line that looks like this. Similarly, if x is 8, then y is 8. So it's this perfect diagonal along this graph. So this is going to be our line that we're going to reflect this L through. Alright, so to do this, we're going to have to figure out distances away and move it that same distance onto the other side of this line. Alright, so if we go up 1 to get here, if we go up 1 and we want to reflect this image in this line, then we're going to go over 1 to get that. If we need to go up 1, 2 to get there, then we're going to go over 2, 1, 2 to get the reflected point. If that doesn't make sense, or if you can't see that, then maybe if you look here, the distance away at the perpendicular of the line, this is about half of this diagonal away, and this one is half a diagonal away. This point is 1 full diagonal away, and this point here is 1 full diagonal away. Okay, so we could do it that way as well. This point here is 1.5 diagonals away, and so it will be 1.5 diagonals away to get the reflected point. This one way over here is 1, 2.5 diagonals away, so we can go a half, 1.5, 2.5 diagonals away. And similarly, this point here is 1, 2, 3 full diagonals away from this mirror line, and so we can move, we're going from there to here, so 1, 2, 3 full diagonals away. And then we can join these points together and get our reflected L shape. Okay, and that's reflected in the line y equals x, which we've drawn here, and I'm going to delete, because now I'm going to put in the line for y equals negative x, and that's going to be for part B. So y equals negative x, what does that mean? That means that if x is 2, then y is negative 2. If x is 6, y is negative 6. If x is negative 4, y is 4. Okay, so the line actually looks like this. Very similar to y equals x, but it goes in the opposite direction. Alright, so we're going to take this L and reflect it along this line and get an image somewhere over on the other side of this mirror line. So we can go 1, 2.5. This point here is 2.5 diagonals away, so we can move 1/2, 2.5 diagonals. We get this point here. This one is 1, 2, 3.5 diagonals away, so we can move half, 1, 2, 3.5 diagonals away to get here. I'd also like to point out a few things. So let's look at a couple different coordinates. Let's take this point right here. Okay, that point, and we can label it point A. Okay, A has the coordinates of 2 and 7. Now, A we can see is 1, 2, 3, 4.5 diagonals away. So if we move half, 1, 2, 3, 4 diagonals away, we end up over here. And where is that? That's negative 7, negative 2. Okay, so this moves over to A prime. Okay, that's the new image, and it moves over to negative 7, negative 2. Let's take this point right here. We'll call it B. B is at 1 and 7. Okay, B is at 1 and 7. Those are coordinates of B. Where does it end up? It is 1, 2, 3, 4 diagonals away, so we'll move 1, 2, 3, 4 diagonals away. Okay, B prime ends up here. And where is that? That's at negative 7, negative 1. There's one final point. I believe we haven't done this one yet. We can call that one C, and it is at 3 and 5. Okay, C has coordinates of 3 and 5. Shouldn't have written it like that. C is 3, 5, and so where does it go? We are 1, 2, 3, 4 diagonals away. We're going to move 1, 2, 3, 4 diagonals away, and ends up over here at negative 5 and negative 3. So if we join all these together, this was C prime. The middle one we know is there from the shape of the L. There's the reflected image in the line y equals negative x. And when we take A, we end up over here. If we take B, we end up over here. If we take C, we end up over here. If we look at those coordinates, 2, 7 becomes negative 7, negative 2. 1, 7 becomes negative 7, negative 1. And the same thing happens with C. 3, 5 ends up negative 5, negative 3. So I'll leave that with you, and we'll approach that with questions that we do working on this.